So laboratory preparation of alkynes. Now, we want to see how a carbon-carbon triple bond is formed. So let me first put an introduction that a carbon-carbon triple bond is formed by elimination of one atom or group of atoms or groups, let me say groups. One atom or groups of atoms from from two adjacent carbon atoms like the same way in alkenes. Like the same way a double bond is formed. Okay, let me say, like in the same way a double bond is formed. So we are going to look at those methods of preparation. And the first method, we shall look at how we prepare alkynes from vicinal dihalides. When we say vicinal dihalides, these vicinal dihalides, one can define them as the compounds in which the halogen atoms are on adjacent carbon atoms. So here we have halogen atoms on adjacent carbon atoms. For example, if you write CH2, Br, CH2, Br. This is where we have the first bromine on the first carbon and another bromine on the second carbon, meaning that halogens are on adjacent carbon atoms. To produce an alkyne, we treat these dihalides with excess potassium hydroxide in ethanol. And this one proceeds by heat. Since you considered the compound with the two carbons, it means you are going to produce ethine, the alkyne with two carbons also. Ethine. So when we say excess potassium hydroxide, the potassium hydroxide should be excess so that we remove these two bromine atoms. If it was not excess, then you can remove one bromine. But the fact that we have excess, two bromine atoms will be removed very well. So how do we do it? We want to see the mechanism for this reaction. You have a dihalide, you have treated it with that. So we have to first react potassium hydroxide with ethanol. We shall first treat potassium hydroxide with ethanol. So we shall have ethanol plus potassium hydroxide. This one will give us CH3CH2, okay, plus, like we did in alkenes, then plus water. Then another case is now breaking this. CH3 CH2O minus K plus, you break it. So on breaking it, we shall have an ethoxide, then plus potassium ion. So now during the mechanism, we have to see what takes place. So during the mechanism, we are going to find out that this one will be the attacking species. And here, we need to see how we shall break the other bond. So allow me say CH. I'm going to break this. So I will say C, H, H. Well, that is CH2. So then I need to put a moment. Let's see how it breaks off. We shall have C. We shall have C. Let me say CH, then I put another H here so that it becomes CH2, then BR. Then I will say C, HH with another BR. So I've just broken it off because I want here a double bond. I need a bond, then this one will first go. So the reaction is like, now you bring your ethoxide ion. We shall do more examples, of course. If you bring your ethoxide, this one will come here. This one will create a double bond here, and this one will go. That is the first step. Because remember, we need a triple bond. So this one has first created, then here we create a bond as this one goes away. So we shall have CH, BR, but with a double bond. Then I have another C, H, C. Yeah. Of course, when you do this, it would mean that you will add this bromide ion. Those ones who have not muted, please make sure that you mute. Junior, you normally give me a hard time. So now it is from this side, because remember we said that we use excess potassium hydroxide. Junior, can you mute yourself? So we shall bring excess of the reagent, or CH2, CH3. To come here, then we create another bond here as this one goes away. Yeah. So now this one will lead to the formation of CH, triple bond, CH, plus this one has peaked hydrogen, so we shall form plus ethanol. Oh, CH3, CH2 OH, then plus this bromine which has been cleaved. Now, it would mean that this potassium which did not react will react with the bromide ion to form potassium bromide. As simple as that. So it's a matter of you dealing with the structure you have to create a triple bond. But that is done only by splitting this and this. Then you put the bromine atoms separately so that you first lose the bromine atom. The moment you have to lose the first bromine atom, you first create a double bond. Then you lose another bromine atom, you create a triple bond. As simple as that. But this example is not enough. Yeah, I'm going to post it to your WhatsApp. So I want really to do very many more examples so that we see how we can fix the understanding. Yeah. So to save time of copying, I've sent that to your group so that I continue. I do more examples. So let's get it clear from this example. CH3 CH BR CH2BR, that is also a dihalide. Provided you see two halogens excess, potassium hydroxide, then heat. Before you start troubling with the product, you can first write the mechanism. You're going to have this CH3, you will not tackle on it, but the main thing are those carbon atoms where the bromines are attached. But first form the attacking species. Then now, this, you form an ethoxide here. So it is from this step now that you come on this CH3. Then now you are going to split the C, where the bromine atom is, that carbon, you have to split it from hydrogen. So we shall say C, hydrogen, bromine. It's as if, of course, here you'll be having bonds. Then we have another carbon. There are two hydrogens and a bromine. Then now you bring this species, which is CH3, CH2O. It's going to come here as you create a double bond here, yeah, as this bromine first goes. So this one will lead to the formation of CH3, C with a bromine. You've created a double bond here. Then C, of course, the Br has gone, so we shall have one hydrogen and another hydrogen. Then, because this one picked hydrogen, we formed ethanol. And the bromine ion, which did not react, this one. So now from here, you bring the excess ethanol, rather the excess ethoxide. You create another bond here as this one goes away. So when you do this, you're going to have your final product, CH3, C, then a triple bond has been created, then C, then H, then plus this one picked hydrogen, so we shall form ethanol. And bromine ions, so all the bromide ions. It is the final step that where you have the potassium which didn't react, plus bromide from potassium bromide. This step is not marked, but you can show it. If you're with me now, type some yes and I see. If you're with me now, type a yes and I see. Let's do another one. Of course, you have to complete here. Let's do this. Hit. Before you stress, the mechanism can give you a product better. You have ethanol. Plus water, then you're going to form CH3, CH2O minus, plus the potassium ion. Then now you bring your ring. So we shall have CH2. I told you we expose or we touch on those carbons with the chlorine attached. So we shall have CH, then Cl, then C, H, H, then Cl. So you're going to bring your attacking species. Then this one will create a double bond here. Then this one will go away. Yeah. So from this, you're going to form CH2, C, Cl, the Cl, but with a double bond here, then C, H, H. In this case, we don't say C plus, we don't have plus H. But this one, here we formed the ethanol because this H came, we formed the ethanol and the bromide ions. So it is the excess that will come here. Then this one creates a triple bond here, the third bond, then this one will go. So this one will give you the product. So that is the product that you're going to form, of course, plus ethanol, and then Br minus, it is Cl now, not Br, Cl. Check, it is Cl. So now this Cl can combine with K, yeah, potassium ion, chloride ion, potassium chloride. That is what we form. If you're with me, some yes. So it is from this that we can move on. Now, these reactions are what we call dehydrohalogenation. One can call them dehydrohalogenation of vicinal dihalides. And as shown, it occurs in two steps. The first yielding a haloalkane. Yeah, the first step yields a haloalkane. Then now another step yields an alkyne. So it takes place in two steps. The first yields a haloalkane with one chlorine, and then another one yields an alkyne. Naming, I'm leaving the part of naming for you. You did much of nomenclature. So I want you guys to name these compounds on your own. Of course, the name must begin with a phenyl, since you have a benzene ring. So let me expect you guys to name this. This is 3-phenylpropyne. Yeah, 3-phenylpropyne. So that is the first thing. Now, one also can as well use the sodium amide. For this case, one can use sodium amide. Yeah. Sodium amide can be used as well. So sodium amide can be used. And this sodium amide, we shall interpret it as a stronger base. So sodium amide can be used. It's a very, very, very strong base. For example, if you have CH2, Br, CH2, Br, and you use sodium amide, NaNH2, in liquid ammonia, sodium amide in liquid ammonia, still you'll form ethine. And the mechanism all begins like this. If you have used sodium amide, you have to do like this. We shall have the sodium amide first dissociating from sodium ion and an amide ion. So this one being a nucleophile, actually we shall use this one to attack. Now this one is like our nucleophile. However, still the steps of splitting are like what we did. So you're going to split this. We shall have C, H, then H, then Br, then another C, H, then Br. So we shall have H2N. So the hydrogen will come, rather the bond will come here as a triple bond is formed and as a bromide is lost. That is the first step. Because you see, the first step is to form a halide. So this one will lead to the formation of HC, as you can see, but this one has been picked to form ammonia because it was H2N. Now you have added another H to be ammonia. So we shall form HC, Br. Then we've created a triple bond here. Then C, H, and another H. Of course, plus ammonia, and then plus a bromide. So you bring back the amide. When you bring back the amide, you come to the hydrogen, and this bond will create a triple bond here as this bromine goes. So this will lead to the formation of ethine and the ammonia and the bromine. Now this bromine will react with sodium to form sodium bromide. And that is it. If you're with me, type yes. If you're with me there, type yes. So it is from this ground. Also, members, we have what we call gem-dihalides. We have vicinal and geminal. So gem-dihalides and what are those gem-dihalides? With gem-dihalides, the two halogen atoms are on the same carbon atom. So in that case, we call it a gem-dihalide. So gem-dihalides can also undergo dehydrogenation, e.g. CH3 Cl2. You see, there are two chlorines on one carbon. You can put a chlorine here, you can put a chlorine up there. So CH3. Excess potassium hydroxide. Ethanol and then heat. Let's see what we get. Mechanism. It all begins with the reaction of potassium hydroxide. At least that first step should be written by everyone. We add ethanol. Shall form CH3. Then water. Then you bring your CH3 shall form CH3. So you bring your dihalide. I guess that is it, because the two chlorine is attached to one carbon. Then it is at this spot that you bring your CH2, CH3. So the first Cl goes, forming now I'm remaining with this. And another hydrogen, because there are two hydrogens, their position doesn't matter. So if this one goes, I can bring this one down. So what I do, I bring back again the and then this one will go away. So this one will lead to the formation of course, one would have added ethanol here because you're forming ethanol also, ethanol, and the chlorine ion, the chloride ion, sorry. So this one will lead to the formation of CH, Oh, here we had a double bond, so he has added another bond. So we shall have CH3, triple bond, CH. Can add ethanol and OH. No, Cl, sorry, Cl. So all those are dihalides. Then now the Cl, this one, can react with this to form potassium chloride. As simple as that. So those are the reactions about the hydrohalogenation of dihalides. These gem-dihalides, one may want to know, because for synthesis reasons, we may need to know how we get these gem-dihalides. A gem-dihalide can be got by the reaction of ketones or aldehydes with phosphorus 5 chloride. So the moment you get like a ketone, like propanone, this is a ketone. The moment you react it with the phosphorus pentachloride or phosphorus 5 chloride, you form a dihalide. For example, that dihalide we've gotten, the dihalide we have used can be obtained by using a ketone of the corresponding carbon atoms. If you want the one of 3, you use a ketone of 3 carbon atoms in presence of phosphorus pentachloride. So that is the first method of preparation. That is the first method of preparation of alkynes. If you've understood the first process, type yes. Then now, this is just the general method we use. Other methods is where you already have an alkene, but you want a bigger, you have an alkyne, but you want a very big, a bigger chain alkyne. And that method, let me call it reaction of sodium acetylides as my other reaction. Reaction of sodium acetylides with primary alkyl halides. With primary alkyl halides. Now, here, this process, we use it to convert terminal alkynes to larger alkynes. This reaction is easy to convert. Terminal alkynes to larger alkynes. So you already have a small molecule. You have a smaller molecule. So guys, here we convert terminal alkynes to larger alkynes or to a larger carbon chain alkynes. So for this case, the general method is you have an alkyne it can be any length, but when we say terminal, or let me call it where the triple bond or where the functional group is on the last carbon, terminal, you have a bigger molecule, triple bond CH. That is a terminal alkyne. Now, when you have this terminal alkyne, you can convert it to a bigger alkyne by first following the following. First pass sodium in liquid ammonia. This one converts it to an acetylide, RC, triple bond, C minus, Na plus. And acetylide is where the sodium replaces the hydrogen to form an ionic compound. So that is the ionic compound you formed, and this is what we call sodium acetylides. Then now this one is treated with an alkyl halide, which is a primary alkyl halide. When we say primary alkyl halide, that is an alkyl halide with one alkyl group. So you can consider, maybe let me call it RX, to form RC triple bond CR. When we represent them like this, the equation has become a bit hard. So let me give you an example and you see what I'm trying to mean. Generally, one can condense this reaction. One can summarize it as RC triple bond CH and treat it with the following reagents. Reagent number 1, sodium in liquid ammonia. And reagent number 2, you can treat it with RX, which is an alkyl halide, to form RC triple bond CR prime. So let's look at an example and you get what I'm really telling you about. Example number 1, it's where you have like ethane, HC triple bond CH. We want it to convert a very big alkyne, but the very big alkyne will depend on the alkyl halide you have used. If you use the alkyl halide of 1 carbon, it means that you will form an alkyne of 1 more carbon. If you add an alkyl halide like CH3Cl, it will add you 1 carbon. So it will add you, it will be CH3CH, rather C triple bond CH. But if you add something like CH3CH2Cl, that it will add you an alkyne with the more 2 carbons because these are already 2. So if you use these, you're going to get more 2 carbons in that alkyne. So the first reagent is sodium in liquid ammonia, and the second reagent, for the start, let me first consider bromomethane. It means that the compound you're going to form will have more 1 carbon because these are 2, 1 carbon, 1 carbon. So you're going to add 1 more carbon. So we shall form CH3, the one of this, then C, a triple bond, and CH. That is what I'm trying to mean. It adds you 1 more carbon. So in synthesis, the moment they say convert this from this, first C is the substance they want me to get having more carbons, or it is having less carbons with the one I'm starting with, so that you see whether you will need to increase the carbon chain or not. We shall get to that as we proceed. So the mechanism for this reaction follows like this. We first get this alkyne, which is ethane, plus sodium first. These 2 first react. This plus sodium. Liquid ammonia is just a base to provide the medium, basic medium. So we shall form HC triple bond C, Na plus. Of course, since we are missing another hydrogen, we can say plus a half hydrogen because there is one hydrogen left. So plus a half hydrogen, so that it comes to one hydrogen atom that hasn't been used. Now, it's after getting this that you split this acetylide. So we shall have HC, triple bond C minus Na plus. You split it, you form HC, triple bond C minus plus sodium ion. Now, you bring this alkyl halide at that stage. So we shall have CH3 with Br. In my introduction, I told you that bromine has a higher electronegativity and therefore pulls bonding electrons toward itself, thus becoming partially positive, and where electrons come from become rather partially negative, and where electrons are coming from becomes partially positive. So after having known this, then you bring your intermediate. We shall bring our HC triple bond C minus. So it will come here as this one goes. For that case, you're going to have HC triple bond C, HC triple bond C, then CH3, which is the same as this. Of course, plus the bromine that you have not used. So this bromine will react with sodium from sodium bromide. If you've understood me, type yes. Because I'm going to give you something after. I will do you one more example, then I give you what to do because I see time is dwindling. Okay, so after this, guys, let me do you one more example on this. What if you have HC okay, CH3, CH2, C, triple bond CH, one, sodium in liquid ammonia, and two, CH3, CH2, Br. This one means that we shall add more two carbons to this. So the mechanism is simple. Shall begin with this reacting with sodium. And will form then, of course, plus a half hydrogen. Then now you'll get your CH3, plus sodium, and then at this point, so you're going to bring this and this alkyl halide. So we have our alkyl halide CH3, CH2, and Br. We know that this one has more electronegativity, so it puts the bonding electrons becomes positive, rather negative, and this one becomes positive. So at this spot, you bring your intermediate CH3, CH2, C triple bond C minus. So it should come like that, and this one will go away, forming CH3, CH2, C, triple bond, CH2, oh, no. C, then CH2, CH3, plus bromine ion, which reacts with the sodium ion to form sodium bromide. As simple as that. As simple as that. Then the last method is the industrial one. Industrially, this one is gotten by basically ethine. It is used to prepare ethine. Action of water on calcium carbide. Action of water on calcium carbide. When you study group 2 elements in organic chemistry, you're going to see how they react with, how their carbides react with water. So how do we get calcium carbide? Calcium carbide, you get it initially from the decomposition of calcium carbonate. When calcium carbonate decomposes, it produces calcium oxide, which is a solid, and carbon dioxide gas on heating, of course. Then that calcium oxide we have formed is reacted with excess coke or carbon, and this is between temperatures 2000 to 3000 degrees Celsius. This one would produce for us calcium carbide. Carbide is from carbon. Carbon is a group 4 element, but you're going to find that carbides have different formulas because of the reasons you're going to find out when you reach group 2 elements. But calcium carbide is unformed, and we form it alongside carbon monoxide gas. Now, hydrolysis of calcium carbide in water, you have to specify which reagent you hydrolyze with, because some hydrolysis take place in presence of dilute acids. So hydrolysis with calcium carbide will produce you ethane and calcium hydroxide. So on industrial scale, you can get your calcium, rather you can get your ethane from calcium carbide. Also, oxidation of ethane can produce, oxidation of methane, partial oxidation of methane can also produce ethane, but those are the main methods. Now, when you hydrolyze magnesium carbide, you get propane. We shall get there. So I won't go beyond this. These are the methods of preparation of alkynes. Our next organic lesson will be on reaction of alkynes. And after reaction of alkynes, benzene will bring itself in action. So I don't want to go beyond this, guys. I want to wish you the best of that day from here. God bless you.